So hello students, hope you all are doing well. So in this lecture we will discuss the different types of inheritance in C++. So the first is single level inheritance. Okay, this is single level inheritance. So what happens in this type of inheritance? Okay, there is a single level, okay, between a child class and a parent class. So you can just see in this way that these are two classes, okay, and the first one is the parent class. Okay, so this is the parent and this one is the child class. Okay, so as you all know that the child class is also known as a derived class. Okay, this is also known as a derived class, and the parent class is also known as a super class. And the parent class is also known as a base class. Okay, so if we just take an example, okay, so in a real world example you can just say that, for example, parent is a desktop. Okay, and from this desktop, okay, we have created or we have derived a new class that is known as a laptop. Okay, so it means that this laptop contains certain features that are in desktop, as well as there are some new or advanced features, okay, that this derived class contains. Okay, so the derived class contains the features of its existing class, that is the base class, and some of its own features. Okay, so in some book, okay, you will just see this type of figure in this way also, that they have just written it in this form, that this is a base, okay, and this is, let us suppose, derived. Okay, this is derived, and you will just see that the arrow is from derived to base. Okay, so here I have just put an arrow from parent to child or from base to derived, but in some books, you can see that the direction of the arrow is from derived to base. So both of these syntaxes or the representations are correct. Okay, there is no anomaly, or there is no, you can say, there is no misconception in these type of syntaxes. Okay, the first syntax says that parent derives child. Okay, so the arrow from parent to child says that parent derives child, and the arrow from derived to base, that is from child to base, it says that this child is derived from. Okay, so this is derived from. Okay, so the meaning of both these arrows are same, but the representations are different. Okay, so in some book you can encounter the first scenario, that is this type of scenario, and in some other book or in some, you can say, other context, you will just encounter this type of scenario, but the meaning of both these scenarios are same. Okay, so there is no need to worry. So you can just correlate the different examples, okay, for this type of inheritance, that is, this is a single level. Okay, this is a single level because there is only one level. Okay, there is a parent and a child. Okay, and there is no intermediate level in between parent and child, so that's why this is known as a single level inheritance. Okay, the next is, the next type of inheritance that we will just read, this is multi-level inheritance. Okay, this is multi-level inheritance. Okay, so as the word says, multi-level, so it means that there are more than one level in this type of inheritance. Okay, so we'll just draw the figure. Okay, so it is very important to understand the concept of inheritance with the help of the diagrams. Okay, because these diagrams or these pictorial representations will tell you the real world problems. Okay, how you can just resolve the real world problems with these blocks. So here we have just created, okay, you can say 3 blocks, and the first one, okay, this is, you can say, a base. So this is a base class, okay, this is a base class. This is a derived class, okay, this is derived one, I can say this is derived one, and this is derived 2, okay, this is derived 2. So here you can just see that this derived one is an intermediate, okay, this is an intermediate class, okay, this is an intermediate base class, okay, this is an intermediate base class for this, okay, derived 2. So the functionalities of this base class will be inherited, okay, to derived one, and the functionalities of derived one will be inherited to this derived 2. Okay, so we can also say that this base class is also a super class of derived 2 via derived 1, okay, because there is a level, okay, so the level is this derived 1. So if we just take a real world example, so we can just say that, for example, the base class is a typewriter. Okay, you can take any example, okay, of your own choice that is easy to understand. So I'll just take base class as a typewriter, okay, and a derived class is a laptop. Okay, so we can say that this laptop has been derived from this typewriter. It means that there are certain functionalities that this laptop contains, and these functionalities are inherited from this base class to this laptop. Okay, and a derived 2, here you can say it is a high performance, okay, it is a high performance laptop. Okay, so it is a high performance laptop, okay, where you can do more, okay, or you can say complex number of computations, okay, complex number of mathematical tasks. Or you can say nowadays, you can say there are certain gaming laptops that are also falls under the category of high performance laptops. Okay, so you can just give an example of some gaming laptops, okay, that contains a good configuration like high GPU, okay, high processing speeds, okay, the, you can say, the cache levels, the cache memory is high. So in this way we can just, okay, map this particular inheritance with this particular example. Okay, the third type of inheritance, okay, the third type of inheritance is very important, that is multiple inheritance. This is multiple inheritance. Okay, so as the name suggests, multiple, it means more than one. Okay, so it means that when there are more than one parent class, okay, when there are more than one parent class involved, and from these two parent classes, okay, or you can say more than two parent classes, okay, we can get a child class. Okay, so you can say this is a parent 1 and this is parent 2. So this is, you can say, base 1 and this is, you can say, base 2, and this is the derived class. This is the derived class. So this derived class will contain, okay, the functionalities of both the parents. Okay, that is, it contains the functionalities of base 1 as well as it contains the functionalities of base 2. Okay, so in real world example you can say, okay, that it is something like, okay, this is a father, okay, and this is a mother, and this is a child. Okay, so a child contains the functionalities, or you can say the DNA, okay, from both its parents. That is, it contains the DNA of its father as well as it contains the DNA of its mother, and it contains its own DNA also, okay, its own features also. So this is an example, or you can also correlate, okay, this example to you can say certain real life example, like we can say that, okay, there is a budget, okay, there is a budget where we can say that this is a defense budget, okay, this is a defense budget, okay, and this is, you can say, this is an agriculture budget, okay, this is an agriculture budget. Okay, so I know, okay, you must be knowing that what is a budget. Okay, so this is a budget. So this budget, that is the defense budget and the agriculture budget, will contain, okay, the total budget of a country. It contains some attributes, okay, that will be required in calculating the total budget for a country. Okay, so here I have just taken the two parameters or only two classes, that is base 1 and base 2. So it can be n number of classes also. Okay, it can be base 1, base 2, base 3, base 4. It means that more than one parent. Okay, more than one parent. So for example, this is defense budget, it can be agricultural budget, it can be, you can say, educational budget. Okay, so all the categories of these budget, when it will be, okay, collaborated, it will be taken into consideration, then it will generate, okay, the total budget. Okay, it will generate the total cumulative budget of the country. Okay, so this is the requirement. So this is the derived class, that is the total budget, okay, that contains this features. So it is an example. Okay, you can also generate your own examples of your choice, that is very easy to understand. So the fourth type of inheritance, okay, the fourth type of inheritance is hierarchical inheritance. Okay, this is hierarchical, okay, this is hierarchical inheritance. So it says, okay, it says that for a single parent, okay, for a single parent, okay, this is a single parent, it can have n number of child classes. Okay, so this is, for example, child 1, okay, this is child 2, okay, this is child 2, this is child 3, and so on. Okay, this is child 3, and so on. Okay, so you can say it is in a form of a, you can say, a tree, okay, where you can have different branches. There are n number of branches, and this parent is the root. Okay, this is the root, okay, and it contains, okay, different branches that constitutes the different childs. Okay, so there is a single parent or a single root that, okay, contains, or from which there are different child classes, okay, that have been derived. So if you take a real world example, so you can just, okay, consider it like this, that for example, this parent is a person. Okay, so this is a person class. Okay, this is a person class, and from this person, okay, the first class is, for example, then employee. So an employee is also a person. Okay, employee is also a person. Child 2 is, for example, this is student. So student is also a person. Okay, child 3, so you can just, okay, take any example, you can just take, okay, prime minister. Okay, prime minister is also a person, and so on. Okay, so you just, okay, you just correlate this type of thing, okay, with, okay, with certain examples. Or you can also, okay, you can also consider that, for example, parent is a plane class. So this is a plane. Okay, parent is a plane class, and the child 1 is, for example, this is a chartered plane. Okay, this is a chartered plane. Okay, and child 2 is, for example, a fighter plane, and so on. Okay, and so on. So there are different categories. Okay, so this is the main generic class, this is the base class from which we have just derived this chartered plane and this fighter plane, and so on. Okay, so this is hierarchical inheritance. The next is, okay, that is the last inheritance. Okay, this is known as hybrid inheritance. This is hybrid. Okay, hybrid inheritance. So in all there are 5 types of inheritances, okay, in C++, and the last one is the hybrid inheritance. So as the name says, hybrid, so it is a combination of, okay, more than one type of inheritance. Okay, so it is something like that. Okay, it is something like this, that this is a parent. Okay, this is a parent, and from this parent, okay, there are two child classes. Okay, so this is child 1 and this is child 2. Okay, this is child 2, and again from these childs, okay, again from these childs we have derived a final class. Okay, so again a final class has been derived. So this is the final derived class, you can say. Okay, so here you can just see in this figure, okay, here in this figure you can just see that there are different types of inheritances that have been depicted here. Okay, so number one is, you can say from here to here, you can just see, okay, if you just see this, so this is, you can see this is an hierarchical example. Okay, this depicts a hierarchical inheritance where there is a single parent and it can have multiple, okay, childs, okay, more than one child. And in this particular scenario, okay, in this particular scenario, you can just see that this depicts, okay, multiple inheritance. Okay, this depicts multiple inheritance when, where what we have more than one parent and a single child. Okay, so this is, okay, this depicts hierarchical. Okay, this is hierarchical. And this one is, okay, this one is, you can say, multiple. Okay, so it is a combination of, okay, so this hybrid is a combination of multiple plus hierarchical inheritance. Okay, so it is a combination of these two types of inheritances. Okay, so you can just, okay, take an example. Okay, you can just correlate this with the help of an example, like, okay, for example, the parent is, okay, the person, so this is a person class. Okay, this is a person class, and from this person class, okay, we have two classes, that is, child 1 is the student. Okay, this is an student, and child 2 is marks. Okay, so these are two subclasses, and from these two, okay, subclasses, okay, these two subclasses will now be the base class or the super class for this derived class. Okay, super class in the sense that super class, an immediate superclass. Okay, and this is an immediate superclass. Okay, so child 1 and child 2 are the base classes, okay, for this derived class. And for example, the derived class will just say this is a result. Okay, this is a result. So from this person we have just derived student and marks, and from this student and marks, okay, we have just, okay, find, okay, the final result of this student. Okay, so in this way we can just, okay, progress. Okay, or you can just also take an example. Okay, you can again take an example. For example, this is a, you can say, machine. Okay, this is a machine, and from this class, okay, you have just derived two classes. Okay, so the first one is a mechanical machine. Okay, the first one is a mechanical machine, and the second one is, okay, so this is an electronic machine, for example. Okay, I'm just taking a hypothetical example. So this is an electronic machine, and from this mechanical and electronic machine, what we have developed, we have developed a product, we have developed a final product. So this is a final product class. So in this way we can generate, so this is a final product class, okay, that contains the essential features from all these classes. Okay, so this is also an example of hybrid inheritance, okay, that contains both multiple and hierarchical. So I hope now all these 5 types of inheritances are clear to you. Thanks.